This video is a follow-up to the previous videos made on Flux.2 Klein models. There are a total of 4 videos explaining multiple workflows, and now I will be adding one to this list. We will be looking at 3 workflows in this video, so let's begin with the face swap workflow. The workflow is simple, but it works better than most of the workflows I see on the internet. These are the diffusion models, GGUF, and the safetensor files. This is the video link you're watching right now, and below are the links to download the model. I'm using this 4B model right now. You can also have the FP8 model, which is smaller in size. The folder location in which you need to place this file is given. After having the file in it, refresh the file list by pressing the letter R. Then select the diffusion model. Similarly, if you are on a system with a smaller GPU, and if you prefer the GGUF file, then download the file from here and place it in the UNet folder. Connect this node, and you're good to go with GGUF models. After the diffusion model, there is a LoRA node with a link to download the LoRA. This BFS Head V1 is the LoRA I am using right now, and below is version 1.1, which I have not tried yet. The LoRA is by realism, and he seems to have made his mission to train the best face swap model. This is the second time I am using his model, and it works great. In the workflow, I'm using the Flux.2 Klein 4B LoRA. There is a 9B model available as well, but remember that both models by Black Forest have different licenses. Place the file in the LoRA folder, and below is a note about keeping the LoRA strength around 65%. That is it, the connection goes towards the guider and then the sampler. The VAE needs to be selected in this Load VAE node, which should be kept in the VAE folder, and the link to download is given above. This is where you type the prompt, which goes into the workflow with the help of this clip file. The link to download the file is given. Place it in the text encoder folder and select the file here. The safetensor file is also present here, but this file is large in size, hence I kept the GGUF node connected. You can get the FP8 files from here, and then change the connection, select the FP8 file from the drop-down, and it should work. The prompts you see here are some of the commonly used face swap prompts we use most of the time. The difference between these two prompts is about the character's hair. It says about using the face of picture 2 and recreating picture 1. And these are the pictures 1 and 2 mentioned in the prompt. Let's run the workflow and see the result. The LoRA strength is at 65%, and I think the result looks good. We can still increase the LoRA weight in case you want a stronger effect. The workflow should work on anime and 3D characters as well. The edges of this character are not sharp, but that will be fixed further in the video. I think the result generated is good. What do you think? Let's see how well it does when we bypass the LoRA. Now we will just be using the Klein 4B model. And this is the result. The LoRA does make a lot of difference. Now let's say you have multiple people in an image, and you want to change only one specific subject. In such a case, you can just crop that section and send the cropped image into the workflow to process. To do that, I have added one more load image node with the InPaint crop node. You may need to install this InPaint crop and stitch node group. After loading this workflow in your ComfyUI, go to the manager and then click Install Missing Custom Nodes. Here you should find the crop and stitch node group that you should install. After installation, restart ComfyUI and reload this page to have it work. I will keep this node as it is. And instead of this image, I will send the cropped image in the workflow. Now this will be the image 1, and I will upload an image. This image will be a good example. Let's preview the cropped image. So now I need to select the section of the image I want to change. In the mask editor, this mask option is selected. Set the opacity here and create a mask. Save the mask, and now let's run the workflow. This is the cropped image that will be used in the workflow. I got the result, and it looks fine to me. But this is just the cropped section. The girls on the left and right are missing. So I will use a stitch node to stitch the remaining image onto the resulting image. I will make a connection to send the remaining image to the stitch node and activate the node. Press Ctrl+Enter to run the workflow again, and this is the result. The result looks good to me. What do you think? Try a couple of different seed IDs, and you should get some interesting results. I will keep this section separate because some viewers will jump to the workflow without watching the video and end up having an error. So to use the cropped image, you have to make this connection, activate the node, create a mask, and it should work. The workflow will be in the description. This is the second workflow to improve image details. This workflow is simple and similar to what we saw just now. This is the safetensor file of the diffusion model. I am using the 9B model in this workflow, but not this file. I am using the GGUF model here. The clip files are similar to what we saw before, and I am using the GGUF files, and this should easily work on an 8 GB VRAM system. This is the VAE and the image I generated in the previous workflow. This is the LoRA Ultra Real version 2, and the LoRA's strength is on the lower side. The link to download the LoRA is given above, and I can see that version 3 of the same LoRA has been released. Let's use the second version of the LoRA for now and see the results. Some images are inappropriate here, so make sure you uncheck these, or instead, you can keep this checked. The prompt used here is what is recommended on the LoRA page. So let's run the workflow. The result looks good. I should be using a comparison node here. I will search compare, and I'm looking for a different node group that should be in this partner node tab. You will need to install the RG3 node group from the ComfyUI manager. Connect the node to have both images in it, and run the workflow. The difference between these images is quite noticeable. I will try this image. If you remember, the edges of the character were bad, which we saw in the previous workflow. It looks great after processing in this workflow. The LoRA is trained on realistic images, hence this result is more realistic than the one I began with. This was the third image I generated using a mask. What are your thoughts on this? The LoRA strength is at 30%, and it looks good to me. This is the third workflow we will be looking at, and there are two samplers. This is the second sampler, which includes a LoRA. The image generated in the above sampler will be without the LoRA, and the image generated by the sampler below will be with the LoRA. The difference here will be very subtle, but it is important because I am generating product images. I am using the GGUF model, the Q5KM model. And these are the clip files. You can use the safetensor file if you want a better result. Below is the VAE. The model goes directly into the CFG guider here. And below, the same model with a LoRA node goes into the CFG guider. I forgot to share the download link for this consistency LoRA. I will be adding that later. I will upload an image of a toy car. The image looks like a plastic toy. The prompt used here is about the same car. I took this prompt from GPT. I asked for a prompt based on this toy car. I also specified using the Flux.2 Klein model because in the older chat, I shared the Flux prompt documentation with GPT, so he should be able to give a prompt for the specified model. So I am using one of the prompts given here, and I will run the workflow. I got the image, and this image is generated only using the Flux model. The car looks more realistic in this image. It is identical to the toy car from the uploaded image, but it looks realistic. The image below, which had the consistency LoRA with a model, looks more like plastic. The headlights look plastic, and this window frame as well. In the comparison node, the difference is clearly visible. So the LoRA was supposed to keep the subject consistent in different images, and the plastic edges are consistent, showcasing the actual product. The image generated using the LoRA definitely has the plastic toy feel to it. And the image by the Flux model without the LoRA is somewhat realistic in all the scenes. The download link to the LoRA has been added. The workflow will be in the description, and you can check that out. So that was it in this video. I hope the video was interesting and or useful. I wish you an excellent day.